Welcome to today's Fireside Chat with AI. I'm your host, John Roy, Managing Director here for Technology at Water Tower Research. Hi, Jordan. How you doing?
Good. How you doing?
Not too bad. So I'm joined by Jordan Greene, the co-founder, EVP, and Chief Strategy Officer of AEye. Now, I should mention that AEye's safe harbor statements can be found on their website. So with that, Jordan and I have had a fair number of conversations, and hopefully this one will be interesting to everyone as well. So welcome.
Oh, thank you so much. I appreciate you having me here.
Sorry for the delay there. So how big is the auto safety problem in the United States and globally?
Globally and in the United States, pedestrian safety is a big issue. It's been on the rise, especially in the United States, with the most deadly year recorded in 2021 since 2005, honestly, when the smartphones were introduced, and really it became a very big problem. And the reason for that is that vehicles are becoming bigger, blind spots are becoming more prevalent, people are driving a little bit more aggressively, and so we're seeing enormous challenges here in the United States with 43,000 fatalities in 2021, as well as globally. It's a problem that's very prevalent and needs to be addressed in the coming years.
Right. Now, my understanding is that Europe is a little safer than the US. Why is the US having such issues?
Yeah, Europe is a bit safer than the United States. The problem here is about 50% worse than other areas such as Europe, Canada, Japan, and Australia. But it really comes back to the vehicles that people are procuring and the way that they're driving them and the environments that they're driving them within. So you have these much larger vehicles that are very common in the United States, everything from the SUVs to pickup trucks to crossover vehicles, which are often the most common vehicles that people are buying. And the way that they're driving them in urban areas, in these cities where you have lots of pedestrian traffic, but people taking aggressive turns and going around these blind corners. And so you're seeing an uptick in the number of accidents that are happening. And when you have those larger vehicles, you have a very, very high correlation between the size of your vehicle and the likelihood of a fatality. You have with SUVs above 80% chance that you'll actually kill someone if you don't see them. And with pickup trucks, I think it's closer to 70%, but still a pretty significant impact that you can have when you're driving in these congested areas. And so in the United States in particular, it has become imperative to address this issue. And I think the standards bodies will be acting on this over the coming years.
Now, that's partially due to stopping distance because the vehicles are heavier and the vehicles themselves are just bigger.
Yeah, it's stopping distance, blind spot. It depends on the problem that you're trying to solve. For highways and even in cities, when you're driving at fast speeds, you definitely need to have enough stopping distance. You need to see an object far enough away, and pedestrians are hard to see. And obviously, cameras and radars have certain limitations that are commonly in vehicles. So being able to see them in bad weather, in bad lighting, in too much lighting, these are problems that you need to address. And you need to be able to then have sufficient reaction time, but also blind spots. Blind spots on vehicles are a big, big problem. And even if you have a blind spot camera, for example, you might not be able to see that pedestrian if they're in a shadow of a building or something like that. So it really comes down to how you can use the sensor suite, cameras, radar, lidar, ultrasonics, and processing to be able to figure it out. But yeah, there is a correlation at higher speeds to stopping distance and detection distance.
Now, can lidar really kick us to a whole new level? Is it that significant?
Yeah, absolutely. I think the important thing to understand is why lidar is important within the whole system suite. And we've talked about this previously, but I'll just do a quick refresher, which is you have cameras that are really good at reading signs. They're really good at seeing color and being able to give you information on, for example, stoplights. But they're limited in different weather conditions and different lighting conditions. So if you have too much light, like when you're using your camera and it's overly exposed, you can't see anything. When you have too little light, when it's really dark out, or when there's an object that might be in like I said, a building shadow, or just blending in, you ultimately can't see them. With radars, they're great in bad weather, but the resolution is really poor and there's a lot of false positives. So the two of them don't always address these critical use cases such as pedestrian safety. And when you can add LiDAR into the mix, LiDAR is the only deterministic sensor. It's the only sensor that actually measures the distance to an object, tells you the exact size, the exact construct of that object, and therefore you can figure out very quickly that's a pedestrian. The camera might not see it, the radar might not see it, but the LiDAR definitely does. And that is imperative when you're driving either in a highway environment at very high speeds and you have something like a pedestrian that's fallen off their motorcycle laying on the concrete, or even in, more commonly in city environments where you have pedestrians everywhere, either at far distances or even right next to the vehicle, and you need to know with absolute certainty that they're there, and therefore if you can turn or if you can stop in time to avoid them.
Now, what role do you think that the government can play in all this? Obviously, they have a big role in all of safety, but how specifically with LiDAR and the sensor suite?
The government is a great forcing function in terms of minimum safety standards to say, hey, this is a big problem. Let's devise a series of tests, these different test scenarios for how you move from a historically very reactive safety mechanism or safety standards to more proactive preventative safety. And that's what they're really focused on right now. We should expect to see new government regulations that set these different parameters for how you have to address pedestrian safety, vulnerable road users altogether. So that's everything from cars to motorcyclists to bicyclists to pedestrians and everything in between, and various different test scenarios for how you address that in different environments, like at night, in too much sunlight, and whatever the different test cases are, they will put those into the standards and say, this is what will set the safety ratings that we will give to vehicles, and therefore then dictate ultimately what kind of safety features can be in vehicles, or minimum needed safety features in vehicles, as well as let's say the more forward-thinking innovation leaders that will drive these safety features being adopted in the higher end vehicles first, and then across the board. So I think what you will see is a lot of the OEMs starting with minimum safety features from a push from the government standards, but a pull from the consumers will drive the earlier adoption of these critical safety features, because people want to be able to not have to worry about having a pedestrian in their blind spot, or they want to not have to worry when they're on the highway that there's a small obstacle that they can't drive over ahead of them and that they can't actually see. And these are the types of things that are driving the adoption of LiDAR into vehicles today.
Now, October is National Pedestrian Safety Month here in the United States. How does AEye's system going to really kind of impact, safety at speed, et cetera? And does it really kind of see everywhere? Does it see 360?
Yeah, absolutely. It depends on the vehicle configuration. We have customers that we work with that have 360-degree coverage requirements where they're using multiple LiDARs around the vehicle to get to that capability. We have other customers that are really focused on highway, but the problem exists there as well. Like I said, one of the biggest corner cases that highway autopilot features are trying to address is a pedestrian that's fallen off of a motorcycle and is laying on the concrete out ahead of you. And you really need to be able to detect that pedestrian in your ego lane with sufficient amount of stopping distance so that you don't run them over. So AEye will be driving this in a lot of different ways, because our system, our LiDAR, is second to none in the ability to detect small obstacles very far away, but also detect pedestrians and other low reflective objects very close to your vehicle. So we have this capability of getting that full coverage and being able to address a lot of those key critical issues. we've demonstrated time and time again being able to see pedestrians at 300 meters, which is super important when you're at high speeds, but in more urban environments. Because you don't know how the pedestrian's going to act over the time that you're approaching them. Maybe they start to walk into the street because they're trying to erratically jump across, whether it's a child running after a ball or a person just trying to get across the street last minute. You need to be able to see that at a far enough distance to stop, or being able to see right up against your vehicle to make sure those corner case blind spot detection issues are addressed, which are becoming more and more prevalent. We have the capability to do it all. And I think you'll see that here in the coming months as we continue to show those use cases and discuss the impact to consumers.
So if you take a step back and you look at the auto transportation world, how do you envision, once lidar is deployed in large numbers, what are we going to be looking at in terms of the world of transportation?
A safer, better place. I'll start there. Obviously, that's the answer that everyone's going to give. But I do believe it. I do strongly believe that lidar is the final piece of the puzzle to address a lot of these corner cases, to address pedestrian safety, to address highway safety critical situations. And lidar is really enabling that. So as lidar becomes more robust, cheaper, heavily deployed across large vehicle fleets, you will ultimately see vehicles become safer, more efficient, and ultimately lead to this world where you're hopefully preventing the vast majority of accidents. Because it's unacceptable that, honestly, between 2005 and 2021, we've regressed. We've added more sensors. The vehicles have become smarter, better, cheaper, but for some reason, not safer. And we should absolutely be able to have safer vehicles and further that progress. And I think that lidar will enable that in addressing things like the pedestrian safety element and addressing things like highway autopilot and highway feature sets where maybe it's not even autopilot, but you have a feature that will prevent you from hitting anything that's ahead of you. That is a great world to live in, because that is where you will have the greatest impact on pedestrian lives and ultimately the drivers and the passengers' lives as well.
Right. And as you scale up, I would think that, cost per unit is going to, start to creep down over time as, systems get better and, manufacturing gets easier, et cetera.
Yeah, absolutely. I mean, that's what's interesting. And that's why I was saying there's kind of a leading and lagging indicators of this safety success. And the lagging indicator is usually safety standards. They're usually setting the lowest, the minimum safety standards that you need to hit. But the good news is you have a pull from the consumers that are saying, hey, we want safer cars. We want cars that you can have higher productivity in without having to run the risk of running over a pedestrian or running into something up ahead of us. And that's what's pulling this adoption. So you'll start ultimately with premium vehicles because people are willing to pay more for those vehicles, and therefore they're willing to pay more for the safety systems in those vehicles. But as lidar becomes more prevalent, as the adoption increases, you'll see the cost come down and the adoption curve grow more steeply across a wide variety of value brands, value vehicles, and then ultimately it will inevitably become a standard across all vehicles, just like backup cameras are today within the United States.
Right. So what is the market opportunity for lidar in pedestrian safety or auto safety in general?
It's a great question. I think today we've seen substantial market validation for the use of lidar. And that use of lidar is going across everything from highway autopilot systems to advanced driver assistance systems that are just using it for critical use cases like pedestrian safety or like small obstacle detection, which often go hand in hand. And that's what's really shown that there's a very, very clear, tangible market opportunity and something on the order of between 5 and 10 million vehicles that will be equipped with lidar in the coming decade. So it's not on the order of magnitude of radar or camera, but you can sure expect that it will follow a similar adoption curve and get there. And we're seeing the signs from the market that are saying, and there's a real tangible market opportunity today that is just the beginning.
Great. Well, Jordan, thanks so much. We'll have to leave it there because we're kind of running a little bit out of time. And I really appreciate you joining us today to talk about, LiDAR and AI's great effort in it.
Absolutely.
So,
thank you so much for having me.
no problem. To learn more about AI, please visit their website or access our research at watertowerresearch.com. And thank you, everyone, for joining us. I do want to let everyone know that the views expressed in this fireside chat may not necessarily reflect the views of Water Tower Research and are provided for informational purposes only. This fireside chat may not be distributed or reproduced without written consent of Water Tower Research and should not be considered research nor a recommendation. Water Tower Research is an investor relations firm, not a licensed broker, not a broker-dealer, not a market maker or investment bank or underwriter or investment advisor. Additional disclaimers can be found at watertowerresearch.com.